Hey there. Today we are going to talk about logarithmic functions. So for any real number y and all positive values a and x, where a is not equal to 1, so there's a whole lot of qualifiers in there, we have these two equivalent statements. If I have an expression x equals a to the y, I can rewrite this and rearrange everything using a logarithmic function so that the exponent, y, is no longer in the exponent. I get y equals log base a of x. So these are equivalent statements, one written in exponential form, the other written in log form. The whole reason we like logs is that if I am trying to solve an equation where there are variables in the exponent and I'm struggling with that, logs can make it possible to solve that type of equations. So sometimes if I have an exponential, writing it in a log form will allow me to solve that equation. Right. So remember some things here, x and the base a and the x inside the log, those have to be positive. You cannot take the log of a negative number. But y can be any real number. Okay. Now we have some special logarithms that have special bases, and these are the ones that you will find on your calculator. The common log is when the base is 10, and it's written without any number in that base position. So we just have log of x. If you see log x written anywhere, then that means it is the common log. It is base 10. You should find a log key on your calculator that is base 10. The other one is the natural logarithm. So this is base e, that funny number. It's an irrational number, kind of like pi. And we abbreviate this using the notation ln instead of log. So that's whenever you see ln of x, that is the natural log of x, or log base e of x. You should see the ln key on your calculator as well. So these are the two bases that you can use to calculate things in your calculator. Any other base, we're going to need some help with converting them to this to one of these common bases. So we're just going to do a few examples with rewriting these, and then we'll call it a day. Sorry, question 2 for some reason not showing up on the screen. Hopefully it pops up in a second here. Okay, so number 1, write the equation in exponential form. We have log base 5 of 125 equals 3. So the thing to remember is the number out by itself, that 3, that is your exponent. The 5 is the base in the exponential form. If you remember those two things, then the third one has to go in the other spot that's missing. Makes it a little easier to convert these. So this would be 5 to the third equals 125 if I convert that to exponential form. These are equivalent statements in two different forms. Oh, and there's my second question. Now let's take 6 squared equals 36 and convert that to log form. So the base is 6. That will be the base on the log. The 2 is the exponent. It will be by itself on the other side from the log in the base form, in a log form. So this is going to be log base 6 of 36 equals 2. Okay, so that's a little practice with converting. The last example here is evaluating this log. Log of 1,000. So there's no base written. That means it's base 10, common log. I can just plug this into my calculator. It's good practice, though, to be able to identify some of the ones that we can evaluate in our head. When I'm trying to figure out what log of 1,000 is, I'm asking myself, 10 to what power will give me 1,000? That will be my answer. Remember, the answer to a log question is always the exponent on the exponential. So 10 to the third power will give me 1,000. Okay, so that's the question I'm asking. 10 to what power equals 1,000? And well, the answer is 3. So log of 1,000 is 3. And that one you can verify by plugging into a calculator.